Today we're going to talk about one of the most important measures in statistics. We're going to talk about the standard deviation. The standard deviation is a measure used to tell how numbers in a data set are spread out from the average, which is the mean or the expected value. A small standard deviation means that most of the numbers are very close to the average. A large standard deviation means the numbers are spread out. Now I've drawn a picture here illustrating three different distributions. The red distribution has a small standard deviation. If you'll notice, most of the points are clustered about 0 and the range of values lies between -1 and +1. The green distribution is a little bit more spread out, which means it has a higher standard deviation. And you can see that while it's centered at 0, the range now goes from -3 to +3. And finally, if you look at the blue distribution, you can see that this is really spread out. It goes beyond -5 and beyond +5, and so the data are a lot more spread out, and hence it has a much larger standard deviation. Okay, so there are two different formulas to calculate the standard deviation. We're going to start with the standard formula. A sample standard deviation can be computed using the formula little s, which simply means that it's the sample standard deviation, equals the square root of the sum of the quantity x minus x bar squared, that result divided by n minus 1. In this formula, n represents the sample size and x bar represents the sample mean. Once again, this is the standard formula. Now, when you're doing these problems with paper and pencil, the computational formula may be easier to use to solve these problems. For a variable x, the sample standard deviation of the observations for a sample is called a sample standard deviation. It's denoted by s sub x, or simply, to avoid confusion, little s. The formula is this: s equals square root. In our numerator, we have n times the sum of x squared minus the sum of x, that result squared, divided by the quantity n times n minus 1. Once again, when doing these problems by paper and pencil, you may find this formula easier to use, as will be illustrated in the next few examples. Okay, so let's do an example of calculating the standard deviation with the standard formula. We start by taking a data set. So here we have some data. There are 10 points, and these points are written horizontally. The first step in the process is to arrange the data vertically. So there we have it. We've written the 10 data points in a vertical fashion, and we've added them up, and the sum is 500. The next step in the process now is to calculate the mean. Well, remember, since the sample size is 10 and the sum of all of the x's is 500, x bar is the sum of the x's, 500, divided by the sample size 10, which gives us 50. We will now write that 50 10 times next to each of the values in the table we're making. So we have x bar, and here you see the 50 is written 10 times. The third step in the process, if you look at the standard deviation formula, is to subtract each x value from the mean. So that's what we're going to do. Here's our third column. 41, which is in the first column, minus 50 in the second column gives us -9. We do this for the remaining 9 values, and the last value, 66 minus 50, gives us 16. If you go back to the standard deviation formula, the next step in the process is to take the results in column 3 and square it. So that's what we're going to do. And there you have it. Essentially, it's each x minus x bar, whatever that difference is, squared. So -9 squared is 81, -6 squared is 36, all the way down to 16 squared is 256. Oh, by the way, when we add up all of these differences squared, we get 494. So now, since the sum of x minus x bar squared is 494, sample size was 10, so we had 10 minus 1 is 9. The sample standard deviation equals the square root of 494 divided by 9, which when rounded to one decimal place is 7.4. Okay, so now we're going to do the exact same problem, but this time we'll use the computational formula. So we need to create two columns, x and x squared. Here's our data, exact same data as in the preceding problem. So let's create these two columns, x and x squared. Not only did we create the two columns, but if you'll notice at the bottom, I wrote the word sum and I added up the totals for each of the two columns. When we added up all the x's, we get 500. When we add up all the x squares, we get 25,494. From a notational point of view, the first column is written the summation of x, and it's equal to 500. And the second column is the summation of x squared, which is equal to 25,494. Now, let's review the formula. The computational formula, little s, the sample standard deviation, equals the square root, n, which is the sample size, times the sum of x squared, minus the sum of x squared. That difference divided by n times n minus 1. The rest of this problem is substitution. We know that n times the sum of x squared, n is 10, sum of x squared is 25,494, so we get a product 10 times 25,494 equal to 254,940. Sum of x, remember the sum of x is 500, we must square it. 500 squared is 250,000. When we plug it in the formula, we have s, the sample standard deviation, equals square root 254,940 minus 250,000 over n times n minus 1, which is 10 times 10 minus 1, which is 10 times 9, which is 90. So we have the square root of 4,940 over 90, which once again, when rounded to one decimal place, comes out to be 7.4.